Hello everyone, this is Malia, and today I'll be presenting my research project looking at C9ORF72, SMCR8, and WDR41 complex as a GTPase activating protein for small Rho GTPases. So here's an overview of the poster, and I'll further go down into detail within each section. So the mutation in the gene chromosome 9 open reading frame 72, or C9ORF72, is the most common mutation linked to ALS. The C9ORF72 protein interacts with two other proteins, SMCR8 and WDR41. Arginine finger of the SMCR8 has a catalytic activity, which is very important for the complex's GTPase activating protein activity or GAP activity. C9ORF72 has been shown to express highly in macrophages, especially localizing to phagosomes and lysosome. So overall, the complex has been shown to be involved in various pathways and interact with various proteins. However, the exact substrate is still not clear. Therefore, the goal of my research project is to locate the substrate for C9 complex. So in order to first get hits on the substrate, we first performed an unbiased affinity purification experiment using macrophage lysate. And then using the hits that we got through the mass spec, we further performed co-immunoprecipitation of the C9ORF72 and the constitutively active substrate, which were logged in the GTP form using the HEC lysate. So if you look at figure 2, it shows all the hits that we got from mass spectrometry, which is a lot of small Rho GTPases. We further took those hits and ran co-immunoprecipitation. So if we look at the last column of this immunoblot, where it says GFP Rho A with an arrow, it shows a weak but a very specific interaction between Rho A and C9, which makes a lot of sense if we look at the background function of Rho A. So macrophages usually take in the debris within phagosomes through the rearrangement of the actin coat around here, which is done by multiple small Rho GTPases. However, in order for the phagosomes to fuse with the lysosomes, this actin coat has to be disassembled, which means that the Rho GTPases have to be inactivated, and this step temporarily overlaps with the localization of C9 complex on the phagolysosome, suggesting that the complex might be acting as a gap for Rho GTPases, or especially in this case, Rho A. So for future, we will be investigating Rho GTPases, especially Rho A, using bioluminescent gap assay, as well as the C9 knockout bone marrow-derived macrophages. And finding the function of this complex will help us identify the pathways to be targeted for ALS therapeutics. I want to thank all the people who have contributed so far in this research project, and thank you for your time. Have a great rest of the day.